Ready? And action, action. So from the beginning, when we told the engineering department that we were going to jump Radical, there was an initial breath that left the room, and then a cringe, and then a long line of questioning about how this was going to be executed. Our customers are always doing ridiculous things with our systems, and that's a huge source of enjoyment for us, is being able to see how the machines that we make go into the world and do awesome stuff. A common question is, how hard can you push MotoCrane systems? And since MotoCrane Radical came out, it's been put into some really, really aggressive scenarios that have tested and really flexed what the system can handle in terms of abuse. We also, in our testing, have pushed it really far, but we've never really gone over the edge and done something that was deliberately designed to maybe break the system, to just see how and observe what the system does at that level of abuse. In a meeting where we were talking about this common question of how hard can I push Radical, we asked that of ourselves, and we came up with the idea of pushing Radical in the most aggressive terrain scenario that we could possibly come up with, which is on a side-by-side, off of a jump, and see how Radical handles it. So the first step in realizing the world's first arm car jump was figuring out the vehicle and the track that we were going to do this at. And Eric on our team got us connected with Kyle Nelson, who has a heavily modified Yamaha side-by-side making over 200 horsepower. And Kyle is the kind of guy that knows how to drive that side-by-side, and he knows the physics of suspension setup and where weight distribution needs to be to make sure that we not only got the vehicle in the air, but we also came down flat and made sure that the jump was going to be executed safely and that we weren't going to get ourselves into an end-over-end roll situation. Once the side-by-side arrived, I assessed the structure and the cage and identified how we would actually get our speed rail rigging integrated into the frame of that vehicle. And it only required a couple of custom bushings that just adapted the various tube size to our standard 2-inch OD speed rail clamps. And from that point forward, we were able to kind of figure out a simple triangulated mount to put the mass of Radical over the rear axle, because side-by-sides are notorious for nosediving when they go off jumps. So we ran Radical in the 9-foot mode using the LS kit, which not only brings the arm into a more reasonable length for a 2-seater side-by-side, but it also reduces the ratio of payload to counterweight. So for the 30-pound payload that we were running much less counterweight because the arm was shorter, and that again reduced the total amount of weight that we were adding to an already uneven weight distribution on the side-by-side. So once Radical was rigged to the side-by-side, we just took a couple of test runs around on the property to make sure that the vehicle dynamics were as Kyle expected it to be, under braking and cornering and under acceleration. After those first initial test runs, we took a look at the jump that was built for this and did a couple of modifications using Kyle's excavator. It just came down to everyone looking around and saying, this is as good as it's going to get, and let's give it hell. And action. Being in the air in a side-by-side with an arm above you and seeing all of that, it almost feels like it's in slow motion when I think back to it. But everything did remarkably well. We came down, you know, on all four wheels. The suspension handled it really, really well. I was super surprised that Radical did as well as it did. INS, which is our gyro stabilization system, is a super important part of this because the vehicle is doing so much squatting and diving in the various conditions of accelerating and then going up a jump and then coming up over into more of a dive scenario and coming down to the front wheels. Keeping the arm level in that highly dynamic situation is important, and INS did great. It kept the arm level, so as the vehicle was changing its attitude, it stayed level and predictable for me as an operator, and structurally was like totally unfazed by the jump. And we continued to jump it time and time again, and it continued to perform just fine. I think we were all expecting that something was going to go wrong, but we just kept getting more aggressive with the speeds and the approaches, and Radical never let up. Everything survived, everything continued to operate, and again, that was really what we wanted to see, is how far can you push a system like this and still come out the other end and keep shooting for the day. When we showed the engineers the footage for the first time of seeing the vehicle leave the ground and then be in the air and then come back down to the ground, the breath left the room, and it was a huge pause of like, oh my God, hopefully nothing breaks. But again, it speaks to the great job that our engineers have done in building a system that has a lot of headroom for this kind of work because we built Radical to perform in all kinds of scenarios. That's really its namesake, is being radical.